All right. Welcome, everyone, to BWP 302. If you're in the wrong session, don't worry, it's happened to me before. There are doors that work. We are excited to share with you how BWP has leveraged AWS CDK to deploy our architecture at scale. My name's Steven. This is JD and Madhav. And you all are here to really understand how your organization can leverage AWS CDK to save time, reduce repetitive architecture decisions, and 3, increase developer confidence as you're deploying new systems. We're really excited to share with you today. We're honored that you spend time with us. Let's get into it. So first, just giving us a roadmap of where we're going to journey with today. First, I'll give an intro into what BWP is, how the landscape of BWP necessitated that we use AWS CDK, so we can understand from a business perspective how CDK would then impact us. Then JD will come on stage, and he'll be able to tell us a little bit more about, hey, here's how CDK actually was working inside of BWP, including examples of pipelines, how we deployed services with it, and we'll look at some architecture diagrams. And finally, Madhav will come on stage, and we'll dive a bit deeper, another layer deeper, into some code snippets and some construct examples, and hopefully give you the tools that you need to be able to do the same in your organization. And at that theme, we also have prepared a GitHub repository that will be widely available, browsable at the end of the session, so be on the lookout for a QR code there. And we're really excited. Also, finally, the conclusion, hopefully, we're hoping that there will be some Q&A time. And if there isn't, if we run out of time, we'll meet you at the outside and be able to talk, and we'll get to know you all. So without further ado, let's introduce BWP. So BWP allows millions of Prime members to shop at merchant stores with the same trusted experience that shoppers have come to expect from Amazon. And merchants can add BWP to their store directly to the product detail page by adding a JavaScript code snippet, and that allows for this button and the delivery estimate to be displayed directly on the page. Or for Shopify merchants, they can also install the Shopify app on the marketplace. For more advanced integrations, we're offering a growing number of APIs and events to really help merchants understand or be able to be flexible with their architecture decisions. We know in the e-commerce landscape, many different merchants have different use cases, different architecture decisions, legacy decisions, tech debt, all these things. And BWP really wants to meet our customers, merchants, where they are. To that note, we are really excited to share how a composable architecture has allowed for these really interesting integrations. So not only do we show the page or show the button and the delivery promise, it's not simply a checkout, like a fast checkout button, but we also have that post-order experience that Prime members know and love with the fast free delivery and easy returns. That's a game changer for merchants' business, where they can now offer the same Prime benefits that Prime members get on Amazon. And at this note, BWP has been shown to increase shopper conversion by an average of 25%. 25%. For those of you in the e-commerce world, you know that conversion is a huge driver. And the merchants that have experienced that lift have been really happy, and we are really excited and encouraged by that number. In order to make all of this possible, though, right, we have to have the delivery estimate, right? We have to create orders. We have to show and integrate with all these different systems. So that creates a really interesting architecture landscape that we need to dive a bit deeper into. So let's look into what might go behind this order screen. So a first obvious service, if we're thinking about services and at Amazon, we are very cognizant of our service mesh frameworks. A first obvious one is order service, right? So an order service is very concerned with who bought what, when, and what quantity, and all of that. It needs to be a state machine for that. So for example, I met Mike, and he mentioned that they recently bought energy drinks, right? So if I'm Mike, I buy an energy drink, an order gets created that says, Mike bought an energy drink at 1:34 on November 29th, right? So the order service needs to be really accurate with that type of information and store that shopper information in a really secure way. But what good is an order if we don't actually ship the thing, right? So Buy with Prime leverages Amazon's multi-channel fulfillment service to ship orders. And what that means is it's using the same Amazon fulfillment network that you get when you purchase something on Amazon.com. And in order to show that little delivery date, right, that says get it by this time, there's a lot of complex calculations, as you can imagine, that would go into inventory, where that item lives in the fulfillment center, right? All the core logic that goes behind showing that same thing on Amazon.com. Buy with Prime had to build a custom integration on top of Amazon services to be able to empower merchants to have that same delivery estimate on their site. Beyond that, we can't really do anything if we don't know what we're selling. So the product catalog needs to be flexible enough to be able to store energy drinks for Mike, but also maybe shoes for me. And they have very different size estimates or different product attributes. We need to be an incredibly flexible product catalog. And finally, in the e-commerce space, you can't really get away from payments. So payments, as some of you I'm sure in the fintech world are aware, is a very complex world where there's a lot of different players, payment processors, banks, regulations, all of these fun things. And Buy with Prime has to address that as well. So these 4 areas, right, they're very different areas. Order, state machine, right? Delivery date, we have to calculate, find out where the thing is and how fast can we get that thing to the shopper. And then not only that, but we have to do it quickly so that on the product detail page, we are very confident in what we show, right? Because that's a critical part of the Prime member experience is knowing when my stuff will get here. And in order to do this, right, we, as you may know, we follow the microservice idea that we create service boundaries around them so that the order service doesn't really have to care what kind of architecture the catalog has or what payment method the shopper checked out with. Its core model is the same regardless of other services. And we apply that to each one of these so that we can have a true separation of concerns. And honestly, it's not just those 4 services. We have a lot more. Here's just a sample size of other services that we have, and we have even more on top of this. PowerPoint's limitations dictate that I can't show you the full thing. But you can imagine that it would get very complex very quickly. And again, not super technical, but there is a network between the services in order to empower an incredibly composable e-commerce architecture. Because again, we're going back to our merchants, our customers. We want to meet them where they are. And in order to do that, we have to be able to flex and change based on their requirements and say, oh, you know what? This merchant really needs to be able to do Y use case that we haven't thought about. And I can imagine some of you in this audience also have that changing set of requirements to meet your customers' needs. And really, AWS CDK has empowered us to create the architecture that will be able to meet our customers where we are. So now JD is going to come on stage, and he'll walk us through an order example of an order service and how CDK was used to build not only the service, but the pipeline and the benefits that we get from going through all of those.
Cool. Thanks, Steven. All right, here we go. Let's take a look at a sample order architecture. And to be clear, this is just an example, though we do leverage many AWS services shown here. Now, you've probably seen this architecture before, maybe when you're first starting out your career, Googling how to create a 3-tiered architecture, or maybe even through a cloud guru. Look, we've all been there before. I certainly have, and to be honest, I'm still doing it. So as Steven mentioned, there are a lot of components and complexities when building a service like orders. Each and every service, not just orders, was designed thoughtfully by our engineering teams to ensure high availability, scalability, security, and more. So that way, your order does not come to my address as much as I want it to. Now, that said, let's take a look into our first layer of our architecture, our API layer, AKA the front door in my lingo, the entry to a club. In this entry, we got the best bouncers and security guards called WAF and Shield. We also got an amazing host named Route 53. Also in this layer, we can set a VIP list with access controls and protection for our APIs. Now, if your order request comes, checks in, and passes the vibe check, unlike me here in Vegas, well, welcome to the party, the compute layer. Like a club, this is your chance to meet and mingle with other people. In our case, services talking to other services. You got catalog talking to content. You got delivery talking to fulfillment. You got payments over there on the dance floor doing the cha-ching. Now, speaking of infrastructure, we use Fargate, simply because we can use containers, run containers, without having to manage servers. See, a wise manager named Yuval once told me that friends do not let friends manage servers. Okay, so back to the club. Generally, you have a certain task or job to do, right? And that's a Fargate pun. Whether that's going to the dance floor, to the bar, or even talking to other people. Similar to our order requests, that order request has a task due. And whether that's to get a phone number, a delivery or an address from delivery service, or credit card info from payments. And now once we got that information, we have to store it. Which leaves our last layer, my favorite layer, the data layer, where that information is stored and retrieved safely and securely. So we got Dynamo, RDS, Elasticache, and if you got a big buck, Aura. So nothing too fancy here. I think we've all had our experiences with SQL and NoSQL queries. All right, so back to the top. We need to ensure a well-architected yet decentralized order service. And again, it's not just for orders. All of our services will play by the same rules and will partake in fulfilling your order. However, engineering decisions and development does not stop there. To ensure our service meets customer needs, we've built a robust pipeline for Buy with Prime. Now, for the nature of this presentation, we'll keep it simple, and I'll guide you through the common stages in a pipeline. But if you're curious to know more about our pipelines for Buy with Prime, I recommend you check out our session that's happening later today at 4 p.m., 301. They got really cool stuff there, and then you can share your learnings in happy hour. I think it's a win-win. So back to it, let's dive into each stage. Starting with the source stage, our developer hub, where developers live, breathe, and beep boop together to make magic happen, where we merge, pull, and push, the key words that define our coding journey. Now, once our code gets finalized, we enter the build stage. And no, we're not just adding muscles, but we're automating tests, downloading necessary tools, compiling, and packaging. This is the powerhouse stage where we turn lines of code into a deployable service. Now, once our code clears the build stage, we enter the pre-production stage. This stage allows us to fine-tune our application, ensure quality standards, and really see how it performs. Really, it's a chance for us to make sure our service does not trip over its own code on opening night. Finally, from concept to reality, the moment of truth, the production stage, where all hard work, innovation, dedication is presented. Countless of hours spent on system design, infrastructure, the many Slack pings at 12 a.m., denied code reviews, and the many more merge requests. This is the moment where all hard work is paid off and our service goes live to users. So that ends the pipeline section. Now let's hit the brakes and let's rewind. We started off by looking at a sample order architecture, sharing the common core services, and peeling back the layers. Then we zoomed into the beating heart of our operation, the pipeline, sharing the common stages needed to deploy a service. Now, blending these two models, these well-architected frameworks, we've in essence created a stellar service, no doubt about it. However, there is something missing here, something very, very important. And that's the actual doing and developing part of it. See, the magic happens when we roll up our sleeves and develop. Now, cranking code for these two models is no walk in the park. Like I mentioned earlier, it takes time and commitment, starting from opening up an IDE, writing code, testing, debugging, countless of log info statements, maybe expensing some blue tint glasses, maybe having a midlife crisis or two, or maybe having carpal tunnel fingers. Guess what I'm trying to say is developing for these two models is no walk in the park. It takes time, and it takes a whole village, and it can get pretty complex. And typically, our developers will use CDK to write infrastructure as code, something we all know and love here, as it offers ease of use with testing, pipeline integrations, flexibility in programming language. And if you like writing in C#, well, my hat's off to you. And let's not talk about those CloudFormation spacing YAML errors. Nope, we're not going to do that today in this lecture. All right, so let me take a moment to pause and paint a picture. We have one dedicated service team in building the infrastructure and the pipeline for it. Now, imagine having 100 or 1,000 teams. This can get tricky, right? Imagine all that time that will be spent on building similar architecture. Imagine all that time that will be spent on onboarding, learning, knowledge transfers. See, as Buy with Prime continued to grow, we needed a way to scale and rapidly deploy fast. Given we had so many existing services and are expanding new ones, we need to make sure that any infrastructure that we're building could be reusable for other services and teams as well. So check this. Here's what we did. Given our developers knew their service best and rather paused teams from building services, why don't we gather individuals from those service teams? Group them together to create a cross-functional CDK team. This team of engineers, the Dream Team, came from all different service backgrounds, and they were responsible for collaborating and creating a repository filled with our CDK best practice constructs for Buy with Prime. And the impact has been huge. This repository, this maintained repository, has been used across all different services and teams. It pretty much standardized the way we deploy any infrastructure provisioning services. And see, the idea really allowed us, for our developers, to focus on building great services and products without having to worry about building infrastructure. So this strategy, in fact, has saved us a total of 50 engineering years. Yeah, we said it. So keep that number in head, and with that, I'll pass to our very own technical maestro, my technical brother, Madhav, who will take you through a gnarly deep dive regarding our CDK constructs. Take it away, Madhav.
Great. Thanks, JD. So before we actually take a look at how this cross-functional team created their strategy, let's actually dive deep into a few of the key CDK concepts that they used. Now, when we think of CDK, we automatically think of the AWS construct library. Now, this library contains basic constructs that generally represent AWS services. And I'm sure, as many of you all know, there are quite a few AWS services, which I guess is why we have so many constructs here. Now, while this library is a starting point, one of the key benefits is that it provides you the ability to create a composition of these services to create complex architectures and solve your needs. So examples of this can include network setups, database clusters, or even that three-tier architecture from earlier. Now, constructs are generally divided into three distinct layers. right? Now, we're going to go into each of these layers and give a brief overview of what these are. Layer 1 are the constructs that are automatically generated from the CloudFormation resource specification. These resources are tied to AWS services and provide a one-to-one mapping for them. Now, an example of this would be if you take let's say a vanilla S3 bucket, right? Now, let's take that one step further. A layer 2 resource is what we refer to as a higher level service construct. Now, these constructs represent multiple different AWS resources, but still tied to one distinct AWS service. Now, these constructs also have various opinionated defaults built in to essentially help your use case. Now, from our previous example, we have that vanilla S3 bucket. In order to make it into a layer 2 construct, we can do this by adding in some of our defaults, right? So let's say that we add in encryption and access logging. Now, layer 3 constructs. Now, these are abstractions that are created by 3 distinct sources. They can be either the AWS construct library, yourself and your private library, or third parties from the community. Now, this is the level where you have abstractions created to solve unique problems. So taking our S3 bucket from earlier, we can make that into a layer 3 construct by essentially making it a source for, let's say, a CloudFront distribution. Now, an organizational strategy is comprised of a combination of different layers, all to solve your unique needs. Now, at Buy with Prime, we said that, well, since defaults can provide the best practices and they can help enforce that, why don't we actually use that to create a common repository for all of the AWS constructs that we use, and then have our enforced best practices in there. Now, before we actually dive deep into some of these principles that the CDK team used, there are a few points that we want to highlight. The first is we're going to be using the term opinionated defaults a lot, right? And we don't want you to be confused. So all this really means is that these were best practices that we considered here at Buy with Prime. This does not mean that it has to be your best practice. Our goal here today is to show you Buy with Prime's story and help you use this as a starting point to identify what your unique use cases are and what your organizational needs are. Using this, we hope that you can extend on this and build your own organizational strategy. Now, the second point is that there's going to be a lot of code in this session. So I'm praying y'all don't start seeing ones and zeros, but as much as for y'all's sake as mine, I'm going to keep the pace a bit slow here. Now, let's take a look at that service architecture from earlier. As JD had mentioned, there's quite a few reusable components here, right? So all of our different architectures, be it orders or payments, they can use many of these services commonly. Now, let's dive into one of these constructs to see what it takes to build a custom construct. And in particular, let's start with JD's favorite, the database layer, or in this case, Amazon DynamoDB. Now, when it comes to databases, I think we can all agree that there are a lot of different concerns that we need to address, right? Well, luckily, CDK provides us the ability to set a wide variety of defaults to our databases. Now, the ones that we specifically want to hone in on today are related to security and operations. So primarily because of how important these are to any organization. So let's actually hone in on billing and encryption. Now, I'm going to start with an example of how you create a custom construct class for DynamoDB. Now, in this example, we're going to be using TypeScript. CDK is available for most of the common programming languages today, including Java, JavaScript, Python, and many more. And Now, I know that there's a lot of you out here who are probably TypeScript gurus. I personally am a huge Java fan, and yes, I'm also talking about the coffee. So as much as for y'all's sake as mine, I'm just going to keep the pace a bit slow here. Now, let's go ahead and define our construct class, right? This construct class is going to help us provision a DynamoDB table. And it's going to be used by any of our service teams from any service, be it order, payments, billing, so on and so forth. So let's go ahead and take a dive into what this code is doing. The first thing that we need to do is import the AWS CDK DynamoDB table construct. This is going to be the base that we use to build all of our other constructs and our custom construct class. Now, once we have that, we can go ahead and define our construct class. Now, this construct class is going to extend the CDK construct and thereby allow us to use all of the defaults that we get from AWS CDK. Once we have that, we can go ahead and override the constructor method. That way, any service team that's using this will be passing in an extension of the default DynamoDB defaults, right? And those are these DynamoDB properties that you see here. Now, once we have that set of properties, we can then create another set of updated properties which will have all of our inbuilt best practices. Now, I want to stop here and say that this is a layer 1 construct. What this means is that any service team that provisions an instance of this custom construct will create a DynamoDB table without any inbuilt defaults, right? So some of you might be saying, well, what benefit does that actually provide me? Why don't I just use AWS CDK for that? And you're right. In order to make this provide some form of a benefit, let's go ahead and convert this into a layer 2 construct. And in order to do that, we want to add in all of the custom logic in the constructor. So as mentioned earlier, we're going to be focusing on billing mode and encryption. I know this looks like a lot of code, but don't worry. All of this is available in the GitHub repository. So we'll have the QR code at the end, and we will be here for any questions. So let's just start at the top and work our way down. Now, we allow service teams to pass in any of the defaults that CDK supports, right? And they should be able to choose what those default values should be. So in this case, we're taking the billing mode and encryption attributes and using those for our custom logic. So let's start with billing, right? Now, as Buy with Prime was building out our systems and testing, we wanted the ability to conserve and save money while also allowing us to scale out as needed. As an organization, it just made a lot of sense to default the billing mode to pay per request or on-demand mode. That being said, we didn't want to block any of our service teams from using provision mode. Now, if their use case really required it, our perspective around provision mode was that we should set the min read and write capacity, but we should not take the max read and write capacity, as we didn't want any of our customers to experience a service outage due to limited system resources. Now, all that logic could be in line 7, but let's actually take a look at another example, right? Encryption. Now, for encryption, DynamoDB uses AWS owned keys, which are owned by the DynamoDB service. Now, while this provides encryption at rest, if a malicious actor actually gets access to the DynamoDB service, they do have access to the customer content, which for us was a big no. Now, in order to deal with this, we actually prefer that we use the customer managed keys by default. All right. That said, DynamoDB also has this pretty nifty feature that if the encryption attribute is set to customer managed key, but none is provided, it'll automatically spin one up for you. Now, KMS keys do result in additional costs, And as such, we again did not want to block our service teams from using another option. Instead, as Jay had mentioned earlier, we do have our pipeline set up, and that allowed for us to flag any potentially unsafe configurations. Now, using this, we then create our set of updated properties, as mentioned earlier, and use that to go ahead and create an instance of that DynamoDB table. So this, as it is a layer 2 construct, right? Any service team that uses this will by default have pay-per-request or on-demand mode billing and customer-managed keys. So now, in addition, if we take a look at how they only have to provide the basic CDK defaults that they normally do for a regular CDK construct. So the other thing we want to hone in on is that all we need to do is create a custom instance of this. And by adding in this standardization, our security teams no longer have to worry about any of those default attributes that we've set. Instead, they only have to look at the attributes which have been updated by our service teams. And now I want to pause there and take a second to reflect on that. How much time and cost savings would we have if this was applied to all of these constructs that you see here today? Right? So let's actually go ahead and take a look at a layer 3 construct, or in this case, AWS Fargate. Now, Fargate is generally fronted by load balancers, be it an application load balancer or a network load balancer. For our specific use case, we do use both, but today we want to focus on network load balancers and their integration with AWS Fargate. Specifically, we want to take a look at how the network load balancer integrates with Fargate, and we create a custom relay that ensures that any request that's passing through that network load balancer is logged using Amazon CloudWatch. Now, creating a relay is a lot of code, right? And I mean, as Steven's mentioned before, PowerPoint is probably not the greatest code visualization tool. So we're going to go into a higher level pseudocode, and for the full example, we want you to go ahead and see the QR code at the end for our GitHub repository. Now, in this example, we can see that a lot of what we do is similar to the DynamoDB example, or a layer 2 construct. We start by importing the basic ECS pattern from the AWS CDK. That's going to be the base that we use to build all of our constructs and our defaults. Once we have that, we go ahead and define our custom JLB relay. Now, this is going to be a separate construct that we created specifically for our integration with Fargate. Finally, we go ahead and create our class, the Fargate cluster. This is going to extend the construct class and be a composition of a bunch of these resources that we're using to meet our needs. Now, there isn't much difference when it comes to the process of adding in defaults here, right? We're going to define our constructor and override that. We're going to take in our default Fargate properties, and then we're going to go ahead and in the constructor define our custom relay. Now, once we have that, we go ahead and set that on our updated properties with all of the other properties that the service team has passed in. And with that, we go ahead and initialize our cluster. So now that is the end of the code section here. So you can all take a sigh of relief. And while I have you, I just want to tell you a quick story. All right. Now, when Amazon CloudWatch came out, our service teams were very excited to use this. Our cross-functional CDK team came together, and in the span of 1 week, they identified all the various configurations that we would want. They created a custom construct for this and integrated it with many of our construct classes, including the one we saw earlier, Fargate. Now, when any service team needs to go and provision an instance of this construct, that process takes less than 1 day, right? That's a cost savings of approximately 6 days, right? Now, imagine if you scale this out to 10 teams. Your cost savings are approximately 2 months. Now, given the scale at which we do things here at Amazon, we estimate that we've saved over 50 years worth of development time using this model. And I know it sounds like a lot, but just think of all the different services we've talked about and how many different teams that are needed for all of these, right? So we hope that with this method, your organizations will also be able to take advantage of this and have a similar time savings. Now, as promised, here is the QR code for the GitHub repository. It has many examples for a lot of our AWS constructs that we use, as well as documentation to highlight what that is. So we hope that's going to help you on your process to create an organizational strategy. Thank you. Oh, shit.
Wow, that's amazing. Thank you for clapping for me coming on stage. I really appreciate it. This was all me. Just kidding. I will plug that repo, though. Madhav has done some great work there. There's some very specific examples that are not bound to the limits of PowerPoint text editing. So I will definitely plug that. So it'll still be available. Don't worry, it's still there. Just to recap what we talked about, right? We talked about the intro to Buy with Prime, understood the e-commerce landscape, saw the impact for merchants, really exciting. And then we went into exactly how we used AWS CDK, both to deploy our architectures, but also our pipelines. And then Madhav finally brought us home here with how to actually build our our layer 3 constructs to really capture all those savings. Now, depending on your company size, you might not achieve the same 50 years of experience, but again, I promise if you use these construct principles, you'll be able to save time, either for yourself or for others, right? Reduce those duplicative or repetitive architecture decisions. You make them once, we like these defaults, and then you move on. And then finally, you increase developer confidence, right? You have pipelines that someone else has built, right? As a service developer, I'm worried on how fast can I make my service? I don't really care about like the nitty-gritty DynamoDB things. I'm sorry if the DynamoDB team is here. I love DynamoDB, definitely a big fan, but I don't want to have to think about it every time I'm building a service. And so that's a huge thing. So now we are here. At this section, I'll plug some other sessions and then we'll get into the Q&A and I'll bring these guys back on. Like we mentioned, there are other Buy with Prime sessions. If you're interested, there's actually, I guess it's happening in like 20 minutes. We will not be offended if you stand up and go. But there's a example of launching a generative AI, with Amazon Bedrock against our Buy with Prime APIs, kind of that, again, meet our customers where they are aspect. Definitely would recommend that. Please check the room number, because I think they might be different. They switched them on us. And then again at 4 p.m. today here in the MGM Grand, we are diving, some other great essays at Buy with Prime are diving into more about the pipelines and the concepts that go into making sure that everything is running smoothly for us. If you're interested in doing business with Buy with Prime, either as a merchant or as a partner, please go ahead and check out our interest list. And don't worry, I'll put that QR code back on the stage. But